In this video, we're going to continue our conversation of air conditioning troubleshooting, and I really want to take a look at how the condensing temperatures are affected by the outdoor ambient temperature, as well as some other conditions. Condensing temperatures versus outdoor ambient will give you a lot of information about problems that could be occurring within a system. Now, this came to mind recently when I saw an article in the Air Conditioning and Refrigeration News that's titled Condensers Can Offer Valuable Insights into System Operation. To give credit where credit is due, the chart I'm going to use is actually developed by John. He's a professor at Ferris State University, and he is a frequent contributor to Frost Lines, which is part of the AHCR news. So to get back over to our simulator here in the background, what I have here is this is actually a heat pump simulator, but it's one of the best that I've seen in a long time. It's simple, but I want to review what's going on here. Okay, so we're going to power this system on. I have it in cool mode. The left-hand side of this, the red side of it, is my condenser. The right-hand or the blue side of this is my evaporator. I have two temperature probes on the system. I have one on the liquid line as it leaves the condenser, and I have one on the discharge line of the compressor right there, okay, before it goes in. Now let's just review real quick what a condenser is supposed to do. It takes the heat from the entire system, which is contained in the refrigerant, as it leaves the compressor. This is my discharge line. This is going to be a high temperature, high pressure vapor. It is a superheated vapor, which just means it's heated over the point. There's a lot of sensible heat in it that's over its condensing temperature. Okay, we come out our discharge line. We enter into our outdoor coil, which in this case is the condenser coil. And the first couple passes of the coil, all we're doing is what's called de-superheating. We're rejecting sensible heat, that's heat you can measure, to the outdoor air. My condensing temperature always has to be higher than the outdoor air temperature or the ambient air temperatures. Once we've rejected a whole bunch of sensible heat, we've lowered our condenser, we've lowered the temperature of the refrigerant down to the condensing temperature. Then we do a latent heat change, where we reject more heat. Now this is latent heat. You cannot measure it. Okay, it's the heat of a change of state. And you're taking that latent heat and you're rejecting it into the outdoor air. Once we reject that latent heat, we begin to take that vapor into a liquid. We then come through the final pass of the condenser as a liquid, and we continue to reject more heat, and this is still sensible heat. And therefore, we are doing what's called subcooling. By the time the liquid refrigerant leaves the condenser, it is now a subcooled, high-pressure liquid. So we're first de-superheating, we're condensing, and then we're subcooling. Those are my three purposes of the condenser. Now, because of the way heat flows, the condensing temperature always has to be higher than the outdoor air temperature, or what we call the ambient temperature. Now, the question always comes up is, what is the correct difference between the ambient temperature and the outdoor temperature? So when we take a look at what I have running here, my outdoor temperature, okay, is currently 95 degrees. Okay, with a simulator environment, I can set that to 95 degrees. So what we normally do is we take our high side gauge, convert it to a temperature, okay? So in this case, it's real easy. I just have to click on it. So I know my condensing temperature, which is my high side gauge converted to a temperature, is 120 degrees. Let's ignore the low side of the system for now, okay? My outdoor temperature is 95 degrees. So we subtract the two numbers, 95 degrees from 120, okay, that is your condensing temperature. So let you do that on your own for a real quick sec. So I have a 25-degree temperature split. Okay, now what should it be? Well, it depends on your SEER of your system. So I'm going to flip screens here real quick and pull in a chart we have. Okay. And what I'm looking at here is a SEER rating on the left-hand side. And let's get rid of that arrow real quick. And the estimated condensing to outdoor air temperature on the right. Okay, so my 25 degrees is valid for a 10 to 12 SEER system. Now, SEER is a measurement of the energy efficiency. If I had a 13 to 15 SEER system, that would drop down to 20 degrees. A 16 plus system, I would be seeing a 12 to 15 degrees. And you don't see them much anymore. A 6 to 9 SEER system could have a 30 degrees. The higher the SEER, the lower the difference between the condensing temperature and outdoor ambient. And that's due to the condenser's ability to reject heat more effectively. So again, you need to know the SEER of the equipment to find the estimated condensing temperature to outdoor air. So let's jump back over to my simulator here. Okay, now the question is, if I raise my outdoor temperature, does it affect the difference between the outdoor temperature and the SEER? Let's find out. Okay, I'm going to take my outdoor temperature up to, let's say it's a toasty 110 degrees down in Florida. Okay, we're going to give this for a minute or two to stabilize here. Notice what's happening in my condensing temperature. It's going up. Okay, the higher the outdoor air temperature, the higher my condensing temperature is going to be. But what have we done with the difference between the two? Okay, now at 27 degrees. Has it affected it a little bit? Yeah, it has. Okay, but remember, we might be pulling more heat into the building as well. The outdoor air temperature will raise my condensing temperature, allow more heat into the building, so the system is going to have to work harder. But we will still maintain that we should still be maintaining, if everything's the same, that outdoor ambient. And 110 degrees is way over design conditions of a building. Okay, so let's pull this down a little bit. I'm just going to pull it down to 100 degrees, and we'll see what happens here. So again, watch that. We want to watch that high side gauge here. Okay, 100 degrees, I'm back to my 25 degree difference. But again, notice what happened here. As long as I'm within the design conditions of the structure or whatever area we're trying to cool, okay, my outdoor ambient is not, my difference between my condensing temperature and my outdoor ambient will stay the same. Now, what happens if I have a dirty coil? Okay, let's think about this here, and I'm going to pull that back down. What happens if all of a sudden I have a dirty coil? Well, let's use our simulator and let's simulate that. By blocking part of the coil, okay, I'm going to block 50% of the coil. What's going to happen to my high side pressures and my high side temperature? I haven't changed anything on the ambience, but all of a sudden there's a larger and larger temperature difference between the outdoor temperature and my condensing temperature. We're now at the 132, 133. Okay, I'm going to unblock the coil before the system trips on high pressure. But the higher, if your condensing temp to outdoor temperatures is too high, look for blockages. Look for reasons the air is not flowing across the coil. Okay, if that coil gets more and more blocked, you're going to see your pressures, notice outdoor temperatures and changing, but your high side pressure and your difference between these two numbers is going to continue to go up. What's happening to your subcooling, okay, and your liquid line temperatures? They're going up as well. Okay, So again, be careful because your outdoor air temperature to your ambient temperature can actually tell you if there's a clogged coil, if if a condenser fan is not running properly, if it's not positioned properly. Believe it or not, sometimes people replace the fans and the fan blade is not positioned exactly properly within the condenser itself. So all of this is affected by this condenser to outdoor air temperature, and this is a pretty important chart to have. So again, this was brought up recently in an article in Air Conditioning Refrigeration News. The tech tips in that newsletter are awesome. Get a copy if you can, but always check your outdoor air temperature to your condensing temperature.